Hi there. Welcome to Computer Science 270 Intro to Programming. This is lecture one. My name's Edward Walsh. I do frequently send emails to students. If you check your inbox, you'll probably see some from me in there. Best way to learn how to use a UML-like diagrams, grab a stack of index cards, go to lecture one. Anytime you see anything interesting about UML-like diagrams, grab an index card, write the question on the front of the card, flip over the card to the back, write the answer on the back, and then keep doing it. Go on to the next page, and if you see anything interesting about UML-like diagrams, grab a second card, and then just keep going until you reach the end of lecture one. We're going to have about 6 lectures where we're going to talk about UML-like diagrams. So by midterm, if you actually do this, you'll have a nice collection of index cards. Where can you get help? Best place to get help is read the lecture notes. You go, well, how do I get to the lecture notes? I'm going to show you how. You go to Canvas, click on the baby, go to modules. We're going to go to module 1, which is week 1. Module, got to find it. Find it, find it, find it. Here it is. And printed lecture notes. And it's right here. And if you click on that, you'll get a nice Word document that contains these notes I'm showing you right now, except they're not web pages. I condensed them down into Word documents to make it easier, because this thing can't handle web pages. I used to have a website, then MJC took my website away from me. Oh, how disappointing, but it is what it is. Moving on. Okay. Da, 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 da. Oh, what else do we need? Yeah, if you haven't done it, set up your MJC email account, set up your Canvas account. We're not meeting on, I don't know, it depends on what class I'm talking to, right? Some of my classes do meet on Zoom, some meet in person. So if obviously, if we're meeting on Zoom, then you got to set up a Zoom account. You probably already have it, otherwise you wouldn't be watching this video. I do recommend purchasing the cheapest USB flash drive you can find. You can find an old one in a drawer someplace that's free. Use that. Um, if you don't have a computer, you can go hop on down to the Magic Lab during normal business hours. They are closed 1 hour for lunch and use one of their computers. They got a whole room full of computers. It's a computer lab. It's a huge room. Got lots of computers in it. Both MJC and the Magic Lab do have a limited, very limited number of student loaner laptops. It used to be you could wait until like the second or third week of the semester to get one because nobody knew about this. Now everybody knows about this. Boom, as soon as the semester starts, they're all gone. So, yeah. Mac users are strongly encouraged to install Windows. Why? Because all the instructions that are in the lecture notes, all the instructions in the labs are written for Windows. Now, if you're an expert Mac user, you might be able to figure out how to convert those instructions to Mac, but it'd be a lot easier if you just install Windows on your Mac, and then you can just follow all the instructions as they are. Not a Mac expert. The Magic Lab, they have some expertise in Macs. If you have a question about how to do this on a Mac, go down there, ask them. I can help you with the easy stuff. How do you get an A for this class? There is only one way to get an A for this class, and that is to turn in work, period. Case closed, end of discussion. Don't bother sending me emails saying, I am, and then fill in something really outstanding, beautiful, magnificent, whatever you think you are, and say, you're going to give me an A for this class, right? Well, I will if you turn in work. You have to turn in a sufficient volume of work to get the A, and the quality has to be good enough, has to be A quality work, and then you'll get the A. That is the only way you're going to get an A in this class. Turn in work. If you don't turn in work, you're not going to get the A. I already told you about ways to get help. Read the lecture. Oh, that's what I was going over. Visit the Magic Lab. We do have a Canvas QA discussion and homework help board. That's there for students to ask questions and for other students to provide answers. You can join or start your own study group. There's a lot of gamers in this class. I'm not sure you want to join a gaming online discussion group because the language you want to make sure there's no polite company within hearing distance, no children within hearing distance. The language is a bit rough, and some of the topics they drift off. They don't always talk about school. They talk about other stuff that you do not want a child to hear. So be careful if you're going to do this. Join an existing study group with a bunch of gamers. You can come to office hours. I post my office hours. So I don't know when you're watching this video, so I can't tell you what office hours I have. I'm saving this video for a whole year, so office hours are going to change during the year. Yeah, if you're willing to turn in homework and labs on or before Friday night, I do most of my grading during the weekends because I have a full-time job. And so by Sunday night, hopefully before Sunday night, you'll see your grades, and then you can decide, oh, that grade is too low. I'm going to do a resubmission and try to increase that grade. If you do turn in a resubmission, I grade the whole thing over again. So you got to include everything in that resubmission. And be aware, if I catch a grading mistake that I made, your grade might actually go down. That is not usual. It's very unusual. Usually the grade goes up or stays the same. But if I catch a grading mistake that I made, your grade could go down. Just be aware because you're asking me to regrade the whole thing. So that's what I'm going to do. I'm going to regrade the whole thing. What are we doing today? We're going to talk about the syllabus, a very light introduction into Alice. If you've never seen Alice, be prepared to go ooh and ah because Alice is amazing. We are going to get a very, very simple introduction to object-oriented programming, mainly the UML-like diagrams. You're like, well, what the heck is all that? Well, we're gonna figure that out as we get into this. So first of all, who the heck am I? Edward Walsh. There's my email address. You can't, I already showed you, you can get printed copies of the lecture notes on Canvas. Canvas is how you're going to turn in everything. I don't know if we're meeting on campus. If you are, you can read that for yourself. Moving on. My goal is to teach you how to write computer software. Period. The dean has other ideas. Their goal is to make sure you do all of this, and we're going to go over this over and over and over again. Just about every lecture, we're going to go over all of this because we're going to have a final exam on this. Did you learn all of this stuff? So we're going to go over it almost every week. And then other objectives. How much computer programming skill do I need to take this class? Absolutely none. There's my top student right there, and I guarantee you on day one, that student knew nothing about computer programming, and he is now, that he or she is my top student in this class. So there you go. Don't need to know anything about this. So why should I take this class? I think computer programming is fun. I've been doing this for 41 years, having a blast. Doesn't matter what your major is. A lot of high-paying jobs require coding. I can give you all these stories. I'll tell you the story of my daughter, business major, never took a computer coding class in her life, sitting at her station, and the manager comes up and says, I need you to write code to do this. And she looks at him, and yeah, you can imagine what the rest of the conversation looked like. Tell you another story. My son, the only computing programming class he ever took was this one. He got hired at a lumber yard to sell lumber. While he was waiting to get trained, he just started walking around, talking to people and saying, hey, you need any tech help? And people, they want to, how do I do this on a computer? And what do I do? And there was actually an employee there still using a typewriter. So he taught her how to use a computer. And then he went out into the lumber yard. They had these big industrial machines. I mean, these things can saw a human in half in 5 seconds. These are huge saws. I've never seen saws this big before, and all kinds of other stuff. And he asked, you guys need any help? And they said, well, do you know how to program it? And he said, I can try. And he did. He programmed it to the way they wanted those big industrial machines to work. Long story short, he is now the tech guy at the lumberyard. Doesn't sell lumber anymore. He's the tech guy supporting. Every time I ask him about this, I get a different story. Sometimes he tells me he supports 3 lumber yards. Other times he tells me he supports 2. Then he tells me, well, because of this almost recession. One of the lumber yards might close down, so maybe it's going to be one or two. I don't know. Keeps changing every time I ask him. Anyway, so there, I gave you 3 stories of why you might want to take this course semi-seriously, because you never know. It could be the path to a future life that you haven't even dreamed about. So it happened to those 3 people. Well, my daughter still doesn't write code, but anyway, my son does. He writes all of the database codes and all those codes to get those machines in the Umberlard going the way that the guys want them to work. Um, and I'm writing code. How did I start? I was doing my electrical engineering thing, and they asked me to build this microprocessor circuit, and I did. And then they asked me, "Can you program it?" And I paused for 1 microsecond. I said, "Of course I can." I had no idea how to do it, but I said, "Of course I can." First thing I did was run down to a bookstore. We didn't have the internet. There was no computers back then. If you wanted to know how to do something, you went down to a bookstore. So I went to a bookstore that had lots of tech books. I got a book on how to program a microprocessor, and I programmed that thing. So they were very happy. So, and that was the start of my programming career. I switched from electrical engineering to software engineer. So it does happen. Okay, enough of that. Moving on. Lots of different instructors teaching this class. Why pick me? Well, I try to make this course really fun. The other instructors, they do boring, watch paint dry on the wall lab programs like banking, like suppose you have a banking account that has $100 in it. Write code so that you can withdraw $10 and recompute your balance. Okay, we don't do stuff like that. That is boring. Watch paint dry on the wall stuff. We're doing animations. We're doing animated stories. We're doing video games. They're all very simple, easy to do. After the lecture, you go, "Oh, this is so easy." And it is. Been writing code for over 41 years. Do work full time. Yeah, I'm going to qualify that statement. Kind of got a family now. Well, the kids are still alive. They just don't live in the house anymore. Okay, I don't know if we'll skip this. If you're on Zoom, you can read that for yourself. Uh, Everybody knows how to type in this day and age. I don't even know why I still have that slide. Believe me, when I started teaching this course, I actually had people who did not know how to type. And I'm going, wow, I haven't seen that now in decades. If you can't come to every class, can you still take a class? Well, yeah, all the lecture notes are right there, and I'm pre-recording this video. Now, access to the video, that's a whole nother issue. Somebody told me that, hey, I tried to access your video and I got this screen that says I need permission. See, that's never happened before. So I don't know if that was a one-off because of the person, or if that is the new standard policy, or I don't know. Somebody has to try to access this video and then send me an email saying, yeah, I need permission to see it. So I don't know. You do have to come in for the exams. We have a quarter term, midterm, and 2 exams for the final. So you have to come in those 3 days to take those exams. So that's the only 3 days you have to come in. Now, I do recommend you do come in just to listen to the lecture. Um, uh, this video is kind of like, okay, you're watching me, or you're not watching me, you're just listening to me and you're looking at slides. I don't know. It doesn't sound all that exciting to me. Whereas you're in a live room, you can talk to people during break. You can, have discussions with the instructor during class time. I mean, that sounds a lot more lively to me. But hey, whatever works for you. Um, you don't need a computer to take this class. The Magic Lab has lots of computers. It is a huge room full of computers that you can use for free. The only restriction is it's only open during normal business hours. They are closed 1 hour for lunch. Okay. If you're meeting on campus, you can read all of that. You don't need to buy any software for this course. All the software we're using is 100% absolutely free. I did that by design. I did not want anybody spending any money to buy anything for this course. You will have to buy some exam books. I don't know what they cost now. So when we get to that slide, I'll talk more about that. We know how to use the internet. My gosh, this is the internet age. If you meet on camp, oh yeah, here we go, Blue Books. So if you're taking an in-person class, we are going to have a quarter term, midterm, and two final exams. So you need 4 books. So they either can be this blue book that you can get at the MJC bookstore. You go to the cash register and ask for a blue book. Some years they're colored green. So I guess you would ask for a green book. Just ask for an exam book, blue. They'll know what you're talking about. If they don't have blue, they'll give you the green one. They comes in 2 sizes. Pick any size you want. If you print in really huge letters, you want the big one. If you print normal size, doesn't matter. Pick one. If you don't want to go to the MJC bookstore because their hours are very limited, and how are you going to get there? And so you can go to any store that sells school supplies and get 4 of these composition books. Okay. Stores I shop at, they're still $1 last time I checked, which was like a month ago. And another store I go to, $1.25. Some of you know what that store is. They got them. So there you go. Everything I do on this course is for Windows. Okay, so if you're going to buy a computer, go get a Windows computer. Make sure you do not get an 11S. Make sure the S is not on there because it's not going to work for this course. You want the Windows 11, not the 11S. So many people got tripped up on this, and they come in on their first day and they're saying, "Oh, I got me a brand new computer," and then I look at it and it says it's an S. You need to trade it. Big disappointment. So let's not do that. Let's just not buy the S. Go straight for the 11. Again, you don't have to buy anything. Go down to the Magic Lab and use their computers for free. Um, uh, we know how to work from home. Gosh, the pandemic taught us that. If we're meeting on campus, you can read all of this stuff. Okay. You get 3 college credits by taking this course. How many hours of lecture keeps changing? It seems like year after year after year. The last time I looked, it set to 2 hours. Um, uh, you're supposed to get a 3-hour lecture, which is why you get 3 credit hours. But MJC figured out a legal way to say, nope, you're only going to get 2 hours of lecture, and then you fill in with this other stuff. Okay, well, hey, it's legal. Go for it. We don't have a lab session. They took that away a couple of years ago. I miss it. It was great. No more lab sessions. How much time do you need to spend on this course? Okay, so for a 3 credit hour, at a typical, I'm going to tell you what happens at a typical 4-year university. For a 3 credit course, you would spend 3 hours in lecture, and then you take the 3, multiply by 2, gives you 6, and that's how much time you're supposed to spend outside of class working on the course. So 3 plus 6. And the way MJC does math, that comes out to 10. Don't ask me, I don't know, but it comes out to 10. So you're supposed to be spending 10 hours a week on this course, unless you're in an accelerated course or taking this a summer course. Well, because everything is condensed, you're going to have to spend a lot more than 10 hours on to catch up. So, but for a regular fall spring course, it's 10 hours a week. I am my official title is senior software engineer, 41's experience as a software developer. Uh, um, 25 years teaching here at MJC, computer science classes. Oh, I got to change that. I don't hang around after the lecture anymore. Well, you're watching this on video. You don't even see a lecture, but anyway. Yeah, I don't like being alone at night. I am afraid of the dark. I got mugged once, so and I try not to be alone in the dark. So as soon as everybody leaves at the end of the night lecture, I'm out of that room. Don't even bother asking me any questions because you want to ask a question and walk with me, that's fine. But I ain't staying in that room all by myself. Let's see. I do send lots of emails. I already talked about that. We already talked about all this. Moving on. Grading. So we have worksheets. So it's going to be every week you'll have 3, 4, or 5 worksheets. So we start off with 5, but it'll gradually go back to 3. There's just so much stuff that you have to know. Big, huge. Well, you have to do 2 more extra ones. Like, these worksheets are like they're meant to be like 5-minute exercises. So not eating a huge chunk of your time. Of course, if you don't understand the material, you're going to have to go learn that first. So that might take some time. Homework is 10 points. We have one homework assignment every week. Lab, we usually have one lab assignment every week, except for the first week we have two lab assignments because we got so much to learn. And they're worth 20 points each. We have a quiz on Canvas, 10 points. A survey is 1 point. All the survey does is how many hours did you spend on this course this week? So I'm tracking it. If the number starts getting up, past 10 for a lot of people, then I say, okay, I got to simplify this course or take something out. And I've been doing that. I keep adjusting this course over and over and over again. So you should have seen it when I first started. People were, I don't know, well, whatever, we're not going to talk about the past. Let's stay in the present. I told you about the 4 exams. Each exam is worth 40 points. So we do have 2 exams for the final exam. One is the dean's objectives. We do not have well, okay, I don't know what course you're in, right? If you're an online course with no Zoom and no meeting inside of a classroom, then there is a discussion assignment. And I haven't done one of those in years, so all of this is probably going to change. So just remember, you're watching a video that was recorded like who knows how many months ago. Late work loses points each day it's late. Um, you can resubmit worksheets, homework, labs, surveys. I don't know why anybody would want to resubmit a survey. It's only worth 1 point, but some people do. And why would you want to resubmit? Well, because you have to get every answer right on a worksheet to get the 1 point, and sometimes that's a little difficult to do on the first go. So you see that you didn't get the 1 point, so you might spend another extra 2 minutes staring at it and saying, okay, I see what I did wrong, and fix it and resubmit and get your 1 point. Same thing with homework. People do resubmissions to get higher grades. A lot of times in lab, if you didn't understand the instructions, you might have messed it up. And so you have a chance to do a redo. Now, redos are due on the same day as the original assignment. Redos lose points each day it's late. And I do have a maximum of 1 week for late. After 1 week of being late, I don't grade it anymore. A grading curve is 90 to 100 is an A, 80 to 89.999 is a B, yada, yada, yada. I do not round up. 89.99999 is a B, is not an A. I do not round up. Now you are aware. Okay, that's about redos. Grades are posted on Canvas. Don't cheat. Oh, I've caught so many people using ChatGPT and cheating like crazy. So it's happening so much now. This is what I do. So if you're cheating on a homework for 10 points, I'm going to put minus 30 for the grade on that thing. And then I'm going to say, we need to have a discussion. And so now you have to come in during office hours and chat with me about what happened. If you're cooperative and you tell me what happens, and I oftentimes change that minus 30 to a -1. If you're not cooperative, then I'll change it to a -1, but then I'm going to file a report with MJC that you're cheating. So it's up to you. If you cooperate, tell me what's going on, where'd you get the answers, that score will change. If not, then we'll just let MJC handle it. So, well, what is cheating? Everybody knows what cheating is. Copying all your answers from ChatGPT, that is cheating. Copying from a neighbor, that is cheating. If you're loaning your answers to a neighbor, you know what the neighbor is going to do with it. They're going to copy it. So I don't care who copied who. Both people get a minus 30, and they have to come talk to me to remove that minus 30. Cheating on exams, I've caught people doing that. Yeah, so you know what cheating is. You made it to college. You had 12 years of public school, most of you. You know what cheating is. I'm going to move on. Homework. What the heck? Oh, let's look at a worksheet first. How about we do that? We're going to go back to modules. We're going to go to module 1. We're going to look at a worksheet. Now, most of these worksheets, you just have to write words, but the first 2, you can actually draw something. But how do you draw something? I'm going to show you how to draw something right now. I'm going to download this. Did it download? Oh, there it goes. Okay, so the first 2 worksheets, you actually have to draw something. So you got to draw something that looks like that. Well, how do you do that? Well, it's pretty easy. You go over here to Okay, why enable editing? Okay, now we should be able to do something. Shapes, we want the oval. Hold the left mouse button down, drag out an oval. Then how do you put dots in there is pretty easy. Go back to home, we go back to insert, go back to shapes, draw that, get that oval thing again, and now you've got this oval here. And then you can, if you grab it in the middle or on the edge, you can drag it wherever you want. So now you've got a dot inside of an oval or on the edge of an oval. How do I get text in there? That's pretty easy too. Go to shapes, grab this thing that has an A inside of a box. That's our uh, text input, and you can write whatever you want. Hello there. Oops. Come on. Maybe it has to be wider. No, it has to be wider. It was doing it, but I couldn't see it. Hello. You can adjust the size of it. Just grab one of these dots and scoot it up wherever you want. You could move this whole thing. Just grab one of the edges and move it wherever you want. And then how do you draw arrows? Arrows are pretty easy. Go over to here, go to shapes, grab an arrow. That's not an arrow. Let's try that again. That is an arrow. Okay. And then we come over here and, ooh, that's not good. Let's try that again. We have to go grab it again. You can't just, once you do anything with it, it's gone. I'm going to hold the left mouse button down and drag and then let go. And there's my arrow. And says, oh, that's a puny looking arrow. Well, right click on it, format shape, and you want to change the width. And so if I make the width bigger, this arrow gets thicker and thicker and bigger and set it wherever you want. Once you have it at the right thickness, you can grab it by this line over here and drag it wherever you want. You can change it. You can drag this. You can move it, do this. So you can do all these things you want with arrows. Can I make this thing hollow? Well, we can try. Format shape. We want fill. And we want no fill. Oh, oh, there. Well, see, we did it. See, there's for that one. What about this one? Let's try it on this one. We want no fill. There we go. Okay, so now you can draw circles without all that stuff in there. Okay, enough of that. Let's go to a homework. Let's see what that looks like. Let's just go to modules, back to home. Module one, let's grab a homework. So homework's just a bunch of questions. Just write the answer. I'm gonna show you the easiest way to do it. You can do it any way you want. I'm just showing you the easiest way to do it. Like I said, you can do it any way you want. I download it. And then find question one. I guess we gotta enable editing. Find question stop that. Find question one, there it is, and then come down here and then type your answer here. I misspelled type, T-Y-P-E, not a misspelling, it's a keyboard, that finger issue. Okay, type your answer here. And then do that for question two, put your answer over here. That's the easiest way to do it. Do you have to do it this way? No, a lot of people, they'll start a brand new document and they'll stick their name on there. It says, it's me. Whoops. No, we'll keep it like that. And they'll go one and type your answer here and then do two and three and four and however many there is. The first homework assignment has 10 questions. Some have 20. There is one in the semester that has 40, and that is the only one that has more than 20 questions on it. And why that one? Because that one covers the most important topic in computer science, data structures. So we want to make sure we thoroughly understand data structures because they do ask those questions at job interviews. So you should at least be familiar enough to understand what the words are that they're asking at a job interview. What do you mean by job interview? For people who are going for software development jobs, web developer, um, um, uh, I don't know, Python developer, Java developer, basic developer, whatever. Anybody who writes code. The only way you're going to get those jobs is go to a job interview, and they will ask you data structure questions. That's what I do with interns. I ask them data structure questions. I want to make sure they understand data structures. I won't hire them if they don't, which is why I ask those questions. Anyway, moving on, moving on. Enough of that. Let's look at a lab. All homework assignments are worth 10 points. Okay, look. Oh, there, finally. I got 2 labs for the first week. We got way too much to do. The first one is real simple. It's an hour of code. What's an hour of code? I'm going to tell you what an hour of code is right now. Actually, if you Google hour of code, you'll get like a gazillion hits. I'm not making this stuff up. There is such a thing called an hour of code. Anyway, so you got all these activities you can choose from. Pick one. If you've never written any code in your entire life, you want to pick the first one. That is the most easiest one to do on this list. And they get harder and harder and harder as you go down further on the list. Now, what is this easy one? Is this guy hyped up on sugar like, oh, this is so exciting, and he's telling you how to draw simple shapes, write code to draw simple shapes on the screen. So you're going to draw like a robot face. You can do something that looks like a worm. I mean, it's really cool. Now, and so if you take that one, that's what's going to happen. You have to, what do you turn in? You're going to turn in a journal file. What the heck is a journal file? Yeah, I knew you was going to ask that question. I have an answer for you. Let's go to Lab 01. And if you open up Lab 01, example journal file, I asked ChatGPT, make up a typical journal file for a college student. And this is what ChatGPT wrote. So you have timestamps. So your timestamps won't be week 1, it'll be timestamps. So about every 5 to 10 minutes, write what time it is, and then what are you doing? And then also include screenshots of anything. So you're gonna, if you do the first one, you're gonna make a robot face. Take a screenshot of your robot face. If you make the worm, take a screenshot of your worm and include it in your journal file. Journal file, you write anything you want. So some people will express some emotions, some won't. Some will just tell you, I did this. And other people say, I am so excited about this. This guy is really great. So whatever. It's your journal. You write whatever you want in your journal file. I just need a journal file. Make sure it covers 60 minutes. You do not have to finish the activity to get your 20 points. All you have to do is participate up to 1 hour. Now, a lot of people do finish their activity. That's great. But there's no requirement. Okay, so that's the first one. Let's go back to modules. Let's look at lab 2. Hardest part of lab 2 is installing Java. A lot of people get stuck on that because you're going to be writing a 3-line Java program. And I already wrote the first 2 lines for you and most of the 3rd line. Okay, let's take a look at this. Let's see what's in here. The first thing you got to do is figure out how to install Java. Well, how do you install Java? Watch this video. This is me installing Java and doing this entire lab exercise. And so all you got to do is watch this video and pause it, and then you do what I do. Now, I'm using a USB flash drive to check my work. So if you want to follow it all the way to the end, then you'll need a USB flash drive. Just find one in a drawer somewhere, or just go to the store and buy the cheapest one you can find. You cannot buy one at a dollar store. I have not seen one at a dollar store for $1. I've seen them. They don't exist anymore. That's ancient history. Now you might be able to find them in a dollar store, but I guarantee you they're going to cost more than $1. Those days are long gone. Where do you buy them? Any place that sells computer stuff, right? Monitors, laptops, any place that sells laptops, they have USB drives on sale. Just walk up down the shelves, you'll find one. Buy the cheapest one, don't buy the most expensive one. Okay, and this is the program you're going to write. Well, you just copy it. See, to get 10 points, all you got to do is get Java installed, copy this program, put it on your USB flash drive, and then type the commands to run, to compile and run this thing, and then take a screenshot of it running, and there's 10 points. If you want 20 points, you'll have to figure out how you're going to change this program. So instead of printing hello world, it's going to print your name, okay? Pretty easy. All you got to do is stare at these 3 lines of code for like 2 minutes, and I promise you will figure it out. And the best way to know if you're right or not is you just, whatever you figure out, try it and see what happens. Compile it and run it and see if your name comes up on the screen. This is a pretty easy Java assignment. the whole purpose of this exercise is to get you to install Java on your whatever machine you're going to use. Now, the Magic Lab, Java should already be installed, so you can skip that step. Okay. We did homework. We did lab. If we're meeting on campus, you can read that all by yourself. I don't need to read that for you. You can read that. You can read that. You can read that. If you want to drop the class, then don't ask me to drop you. You go to my MJC and drop yourself. Okay. I don't recommend dropping because I think this is, you may not know it yet, but this class could determine your entire future. I told you about my son. I told you about me. I told you what happened to my daughter. And you're going, well, that ain't going to happen to me. Well, if you get an office job at a big company, then it could happen to you. I've seen this a lot. Uh, a project needs some help with code writing, and they will just randomly ask people, "Hey, can you write code? You want to join our project?" So if somebody asks you that, you got two ways to go on this. You can say, "Nope, not in my job description. I don't have to do it." No, okay, well then they'll just go on to the next person, the guy, your buddy, your next door neighbor, and they'll say, "Hey, can you write code? You want to join our project?" That person might say, "Of course I do." Might not have the foggiest idea how to write code, but they're going to say, "Yes, I will. I will do it." Um, and the person will join. And if that person does a good job, I mean, this is what happened to me. Okay, I didn't know how to write all this code. I figured it out by buying a book. And if you do a good job, then kudos because you're not part of a programming. You're not a software developer. You'll get special recognition from management saying that you went outside of your box to do something to help the company. Managers will notice this. Your name will be mentioned. You'll be invited to other programming um, projects, and this is going to greatly expand your network. What's a network? It's not internet network, people network. The more people you know at the company you work at, if you work for a large company, the better chances you are that you're going to get recognized with pay raises and promotions. If you don't know anybody at your company, the managers won't know you. And then I don't know about other companies, but at our company, the managers actually sit in a room and they close the door so nobody can hear what they're talking about. And they talk about the employees who deserve recognition or a big promotion or a pay raise. They really do. They tell us this. That's what they do. And if nobody knows you, then nobody's going to care. And so you won't get the pay raise. You won't get the promotion. That's why I think you should not drop this course. You should try to finish it. Um, and it doesn't matter if well, I'm not a programmer. I don't want to do this. Well, you're doing it for your future. You don't know if you don't like programming or like programming until you try it. You haven't tried it yet. I guarantee you, if you watch that guy high on sugar doing his thing, you're going to love that guy. There is no way you can watch that guy and then follow along and make your robot face and your worm without saying, this is really cool. I guarantee you, you're going to have fun. Okay. If you have a course meets on campus, you can read that all on your own. I do send emails a lot. I already talked about 10 hours. If you have no idea what computer programming is, this thing is like written back in the Stone Ages. It's very basic. It tells you this is what a computer program is. Okay, you should watch that. This is the one everybody should watch. This is a bunch of computer science grad students actually using their programming skills to help the world, not help some tech company make another dollar. These people are out there making a difference in the world. It is so fascinating. There's this one student who's trying to figure out how to do braille better for blind people. Blind people read by braille, so they have the stiff paper and they poke holes or stuff in it. I'm not sure. I don't read braille, so I don't know how it's done. And this one person took it on and says, "I can make this better." And she wrote all these computer programs to figure out how to get the punch the paper exactly the way that she wanted it. And then she tested the stuff on live blind people. Says, "Is that better? Is it worse? What do you think? What can I do to help it?" And it's amazing to watch this. Another person decided he was going to build these. This was a long time ago, before these things were invented yet. How do you find people who are fighting forest fires that are spread out all over the forest? So he decided, oh, we're going to put a little beeper on all of them, an electronic beeper. It doesn't go beep beep beep. It sends through a radio wave a message to the command post, and lets them know where they are. It's kind of like GPS. This is before smartphones and all this other stuff. So this video is probably really old. And then he wrote all the computer program to make all this happen, so that the the post can see where all the firefighters are. And they need that, because sometimes the wind changes and the fire then, instead of blowing this way, it blows another way, which could be dangerous because it might be coming back on people. So, and he talks about all this stuff, and it's really cool. And then there's like 3 other people helping the world. So you should watch this. It's really interesting. It'll open your eyes, saying, okay, so it's not all about sitting in a dark basement, banging on a keyboard, eating pizza, and drinking soda. No, not for these people. They're out there in the world, helping the world. Um, so, um, I want to start off by, well, what the heck is computer programming and how do we do it? Start off by talking about this video game. This actually did exist, and we actually did this for our first lab back in the old days. This thing no longer exists, but it did for a many, many years, and I used this. I still like to talk about it because it was fun. Um, um, what this thing was you drew your own little video game, and this was pretty easy. So you picked some avatar. It could be a monkey, it could be some other character, and then you picked all these different levels or platforms, and this monkey would jump from platform to platform to platform. Now this whole thing was a big screen, so it had you could put dozens of platforms and put it wherever you wanted. And then this is the goal. So the idea of this game is go jump up from platform to platform to platform until you jump into the goal, and then you win the game. Now, if you miss the platform and you fall to the ground, then you lose the game. And that was the video game. And I like to talk about this because it leads up to the very next thing I want to talk about, is how do programmers make video games? So how do you eat a 24-inch pizza? I guarantee you do not try to pick up a 24-inch pizza and try to eat it. What you're going to do is slice it, because once you slice it, now you've got smaller pieces to work with that are easier to handle. Well, that's what computer software developers do. They take this humongous program that somebody is paying them to write, and they divide it up into smaller pieces. Well, how do you do that? Well, if you're doing object-oriented programming, you're dividing it up by objects on the screen. We have, on this video game, we have a monkey, we have a platform, we have a goal. So that's the first cut. They will say, okay, we need to create a monkey object, and then so what are the attributes or characteristics of this monkey? Well, it's got an image. It had several images, because if you hit the right arrow key, it started walking. So it had images for walking, it had images for jumping. If you hit the up arrow key, had a whole bunch of images. It had a size, like a width and a height. It had a position on the screen, because it's bouncing, platform to platform to platform. It's constantly moving. And those are some of the attributes of the monkey. These platforms, they look like real platforms. They didn't look like a little blue line. I mean, they look like real platforms you'd see at a construction site. And they all had different characteristics. Some of them are like stone. You could stand on them all day long and absolutely nothing would happen to you. Those are kind of boring. They had other platforms that if you stood on them for too long, then the platform would break and you'd fall through and hit the ground, and the game is over. And then they had all kinds of other platforms that did all kinds of other things. So a wide variety of platforms to pick from. And they look like real platforms. The goal looked like a real goal, not some circle on a screen. It looked like something that you would actually want to reach. So I don't remember if it was golden colored or not, but that's how I'm picturing it. But I could be totally wrong. It's been way too long since I've seen this video game. So we already talked about the 3 objects, and here are some properties I came up with for the monkey. Size, position, how high can the monkey jump, how far can the monkey jump, how fast can the monkey jump, how fast can the monkey walk. These are all characteristics or attributes of a monkey. This is what defines a monkey. Um, and all these different graphic images of it doing stuff. Some of the methods or actions that a monkey can do, we call it methods. Most people say those are actions. What can a monkey do? Well, it can stand still, it can jump, it can walk, it can fall, it can cling onto platforms. And then I probably did a whole bunch of other stuff that I have forgotten about. What about the platform? Well, it definitely had an image. It didn't look like a blue bar. It looked like a real platform from a construction site. It had a width. It had a height. How tall was it? Where is it on the screen? And and okay. And then what about actions? Well, like I said, if you some of them you can stand on them all day long, nothing happens. Some you had a time limit, you had to get off that thing very quickly, or you're gonna fall through the platform or over the platform or whatever. I don't remember every. I remember the whole. That was so cool. Your monkey falls right through the platform and hits the grass. um, um, I don't remember if any of the platforms moved, but if they did, that would be another action that a platform would do, move. But how would it move? Does it move left to right, or did it always just move to the right? And when it got to the right end of the screen, does it circle back around and start over again? How did it move? And so those are some of the properties and actions of a platform. We'll see. I got the image, the size, where is it on the screen? Um, yeah, if it's moving, what direction it's moving, or is it going back and forth? And some of the methods is move the platform, stop the platform. So that's what I got. And the last thing is the goal. Well, the goal had an image. It didn't look like a circle. It looked like something you actually would like to have. It had a size, a width, and a height. Position on the screen. You can put the goal anywhere you want on the screen. I always cheated. I made mine real easy to get to, so you wouldn't have to jump very far. Other people, they made it really difficult. I mean, you had to get a running start and jump right at the right moment to reach the goal. Um, and if the goal is moving, how fast is it moving? What direction is it moving? Um, and some of the methods of the goal is move the goal, stop moving the goal, fall through the goal, and all. Oh no, that's a platform. Move the goal or stop moving the goal. I guess that was the only thing you could do. Um, Okay, well, this game would be a lot more interesting if these objects could interact with each other. So you would, and so you would have to define all of that. So what do you mean? Well, think of a baseball game. You got a pitcher throwing a ball to a catcher. So those two people are interacting with each other. Um, well, in a video game, you have characters that interact with each other. Some events that this game could respond to was if you press down the right arrow key, that's an event. The monkey would walk to the right. If you hold the left arrow key down and walk to the left, you hold the up arrow key, it would jump up. I'm not sure if it did anything else. It might have. I can't remember. It's been years since I've seen this video game. Some of the other events besides the arrow key is if the monkey reaches the goal, the game is over and says you win or winner or something. It did something, it made a noise and it says you won. Um, something happened if the monkey hit the top of the screen, the left or the right edge of the screen. I can't remember what happened, but I remember something happened. And when the monkey collides with the platform, the software tries to get the monkey standing on top of the platform. But if you're just barely hanging on, then you're gonna fall off. If the monkey walks off the platform, you fall to the ground or maybe to another platform beneath it. But something's gonna happen. You're gonna fall. Um, or I guess this was the goal. I don't know. I lost track. Okay, doesn't matter. We're moving on. The game no longer exists. Well, what does exist? Alice exists. Um, Alice is used to teach high school children how to write Java code. It's really fun. We're just going to do a very brief introduction to Alice. Um, we're not going to use Alice in this course. I just want you to see that you can divide a video game into objects, and objects have properties or characteristics, and they can do stuff. They have actions. We call those methods. I'm going to start by just picking a background of green grass because I want to put Alice on this green grass. Okay, there, finally, I'm going to set up the scene, which means I'm going to put an avatar on there. My avatar is going to be Alice. That's a person, so I'm going to pick on person. There's Alice right there. So this is the original Alice. This is the new Alice. I like the original. I'm used to seeing it. So I always pick the original Alice. Here are some of the properties you can change. So Alice looks pretty good right now, but I can make Alice look really sick that you wouldn't even want to get anywhere close to her by changing her color to yellow. And now she looks really sick and you want to stay away from her. Well, the color is one of the properties that we can use on Alice. I'm going to set her back to white so she looks healthy. Um, if there was some background stuff, we can make Alice like a ghost so you could see through her, but we don't have anything in the background, so we can't do that. We can definitely change the position. I'm going to make Alice move to the left. There, I changed the position. Alice moved a little bit to the left. I can make her move, go back to where she was, the position. So position on the screen is a property. Size is a property. I'm going to make Alice about twice as big. So Alice is much bigger. I can shrink her back to her original size. Maybe. Okay, and now she's back to her original size. So these are some of the properties of Alice. So we've got Alice. Let's go look at some code. We're going to make Alice do some stuff. So these are the actions that Alice can do. First thing we want Alice to do is just say hello. So grab this say hello thing and we're okay. So we'll just say, yeah, we're fine with just saying hello. So let's do that. Then I want Alice to turn. So let's turn her to the left, which means it's going to turn that way. It's Alice's left, not your left. And we're going to turn a quarter turn. And then we're going to make Alice move. And we're going to move in the direction she's pointing at. And we'll make her move just a little bit, not very far. And then I want Alice to turn back to face us. So another turn. And this time it's going to be right. And we'll do a quarter turn. And then I'm going to try to make Alice say bye-bye. Sometimes I have trouble with this because I really don't know what sequence of keystrokes I'm supposed to press to make this happen. Obviously not that. What about this? Oh, wait, something happened here. There we go. Bye-bye. And say, okay, okay. So now we've got Alice doing some actions. These are all the actions that Alice can do. Let's run this program and watch, see what happens. There's Alice saying hello. She turns. She's going to turn back to face us and say bye-bye. Okay, that's it. You can do all kinds of other stuff. This is a brief introduction to object-oriented programming. We're moving on. Step by step, everything I just showed you. So if I went too fast and you want to redo all of this, first thing you got to do is download Alice. It's a free download and just follow along. I do want to talk about this UML-like diagram because you're going to see this all the way till the end of the semester. The UML-like diagram is divided into three parts. The first part is the name of the class. What's a class? It's a factory. This class produced the Alice factory produces Alice objects. So remember, to do a video game, we actually have to have a real Alice object on the screen somewhere. Well, what makes the Alice object? Well, the class, the Alice class, and that's what this is. It's the Alice class. Going, this is way too confusing. Just think of this as the Alice object, okay? Because the factory is just going to make Alice objects. These are all the properties that we saw that came with Alice. So we did paint that made her look sick. We couldn't do opacity because we didn't have anything in the background. XYZ is the position on the screen. Where is it on the screen? Width, height, depth is how big Alice is. If you change one, the other two will change. Well, I think it does. The last time I tried it, it did. And then here are all the methods or actions that Alice could do. We did say hello and say goodbye. We did a move. We did a turn. And then here's some other stuff that you can play with if you want to try some of this other stuff out. Okay, so given this UML-like diagram, how would I change Alice's color? So why am I even talking about this is because the hardest part of this course is to convince students to look at the UML like diagrams when they need to look at it to get the answer. A lot of people will just change the color property to yellow. Well, there's a problem with that answer. Find the color property. That's not it. Nope, 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 no, 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 no. Okay, find a method that changes the color property. Nope, 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 nope. So that ain't it. Because there's no color property. There's no way to use a method that'll change the color property. So the answer is not color property. Well, what is the answer? Well, you've got to look at the UML like diagrams and figure it out. And you can do this by process of elimination. So it's got to be a property. I already said it right there. Well, it's not going to be show joins. Oh, by the way, you don't want to do that if there's young children next to you. You'll scare the living daylights out of them, and mama is not going to be happy with you. This has to do with how big Alice is. This has to do with Alice's position on the screen. This has to do if you want to make Alice a ghost. And so the only thing that we got left is paint, and that's what we use to paint Alice yellow. So if we want to change Alice to yellow, we have to use the paint property. Okay, and the only way I could have figured that out is by looking at the UML like diagram, because most people would just say, well, change the color property. Well, there is no color property. You got to look at the UML like diagram, figure out which property or which method you have to call to make the change that you want. Okay. There is no set color property, but there is a set paint property right here. Okay. Again, you wouldn't know that unless you actually looked at the UML like diagram. Hardest part of this course is to convince students to look at the UML like diagram. If you can do that, you are more than halfway set for success in this course, because that is the hardest thing in this course is to convince yourself to look at the UML like diagram. It's all downhill from there if you actually do it, if you actually do look at the UML like diagram, because it tells you everything you need to know. Okay, this is talking about the colors. We're done with all that. I went through every property. I already did that. Yeah, if you're interested, you can download Alice here. It's a free download. You want to get Alice 3. That is the latest version of Alice. You don't want to be playing around with the old Alice version. Go to 3. Okay. Moving on. So what did we learn so far? This is not the end of the lecture. We still got a lot to talk about, but I just want to summarize what we've done. We decided that the easiest way to make a video game or to any kind of software is divide it up into objects. Now, if it's a video game, you look at all the objects that are in the video game. For Alice, we had the ground. Remember the green grass? We had the sky. There was some sky above the green grass. You might not have noticed, but it was there. There's a camera that we couldn't see. Why? Because we're looking through the camera lens, so we can't see the camera, but we could have moved the camera if we wanted to. And we had the avatar, Alice. Each one of these objects have properties. So for Alice, we had the image, we had the position on the screen, we had the size. Well, it wasn't size, it was width, height, depth, etc. And paint property. And we could make Alice do stuff with some of these methods. We made Alice say hello, we made Alice turn, we made Alice walk. So these are some of the actions that Alice could do. A character can respond to different events. So on that first video game that I showed you with the that monkey and the platforms and the goal, you control what happens in the video game by pressing on the keyboard. So if you press the right arrow key, that's an event. The monkey responds to that event by walking to the right. And if you press the left arrow key, it responds by walking to the left. And if your monkey reaches the goal, that's another event. The game is over. You win. If your avatar hits the ground, that's another event. The game is over and you lost. So those are some of the events. Let's look at something really simple. We're going to look at this UML like diagram for a car. We divide this UML like diagram into 3 parts. This car is the class. It is the factory that produces car objects. Okay. And the only property we have for this car is color. That's it. That's all we got. And the only actions or methods that we have for this car is go backwards, and stop. So again, the most important thing about this course is reading the UML-like diagram to answer questions. That is the hardest part of this course, convince people to do that. I don't know why it's so hard, but a lot of people, they can't do it, or they won't do it, or they don't give it enough importance to even try to do it. So I don't know. All I know is at the end of the semester, I still have a small handful of people that just absolutely refuse to look at the UML-like diagram. They just look at it and stare at it and go, I don't know. Am I supposed to use that? I don't know. Don't be that person, which is why we're going through all of this right now. Don't be that person. Okay, so I already talked about the properties and the methods. Let's move on. So with this one car factory, it's a car class, this car factory. Car class is the factory that produces car objects. I can make different colored cars. What do you mean you can make different color? I can make all. So car factory makes cars. So you can make one car, or you can make millions of cars. If you want the cars to look different, you've got to change the value of the property. So here's a car that comes off of this car factory, and I set the color property to red. I can make 3 more cars and set the color property to green. I can make 2 more cars and set the color property to blue. These are different cars, but they all come from the same factory. Okay. Hopefully this is making sense. Why can't we change the number of doors our car has? Stare at this for a few seconds. Why can't I change the number of doors? If you need to hit the pause the video to think about it, do that. I'm going to tell you the answer right now. Is because there's nothing in here to change the number of doors. There's no property for changing the number of doors or setting the number of doors. There's no property to change the number of doors. There's nothing here. The only thing we can change is color. Okay. Hardest part of this course, convince people to look at the UML-like diagram. That is the hardest part. Why can't our car turn right? Well, you got to look at the UML-like diagram to figure that out. This car can only do 3 things: go backwards, and stop. There's nothing in here to let it turn right or left. That's why you can't make a right or left turn. You go, well, what kind of crazy car is that? There's lots of video games where an object just floats from the left edge of the screen to the right edge of the screen, or vice versa. Duck Hunt, if you ever played that. And there's all kinds of games where stuff just moves in one direction. Okay, we talked about that. I really recommend you do this exercise. Get a pause the video, get a sheet of paper out. I create the UML-like diagram for a dog. So you in the middle, you want to put the properties of the dog, and at the bottom, you want to put all the actions that the dog can do. So pause the video and actually do that. I'm going to move on. There's no point me sitting here in real time waiting for you to finish this. You can just pause the video. Then when you're done, you can resume the video. So that's what we're going to do. We're going to the next slide. Here are some properties I thought up. Now, there's a lot more properties of dogs than this. This is just the ones that came up on the top of my head: breed, name, age, weight, gender, height, length, eye color, fur color, and the list goes on and on and on and on and on, right? You can think of a million things. Put 2 dogs together and just start looking at them, and you can see millions of differences. What are some things a dog can do? Well, I came up with sit, bark, growl, eat, walk, run, sleep, and the list goes on and on. I mean, you can roll over, play dead, jump, go swimming. I mean, if you ever owned a dog, you know this. Okay. So I picked sit, bark, and walk. So this is so for your first homework assignment, you're gonna have to make a UML-like diagram. It won't be for a dog, because here's the answer. It'll be for some other object. But just remember, you have to draw this box. You have to have 3 lines. How am I gonna draw the box with 3 lines in it? Well, I'm gonna show you how to do that right now. This is how I do it. Go to Excel. Start with a blank document. Let's up the font. Yeah. Okay. And let's say we're going to do dog. The name of the class is dog, and let's say the properties of our dog is age and breed and weight And then what are some things this dog can do? This dog can bark. This dog can, I don't know, jump. This dog can wag tail, okay? Wag tail. I'm just making stuff up, okay? But now we got to draw the boxes. So, if you turn it in like that, you're not going to get very many points. You might not get any points at all because I'm going to tell you, draw the boxes. Well, how do I do that? Come over here. You want to pick thick border. Then you want to grab all other properties and do that again. Pick thick border, and then grab all the methods and do it again and pick thick border. We'll go, well, that's great, but how do I get this into a Microsoft Office document? Pretty easy. Just copy it. Right click, copy, go to Microsoft. And paste. There you go. Okay, easy peasy. I mean, I cannot make this any easier than this. I mean, this is so easy. I mean, if you say, I can't do that, well, so what you can do for homework and for the worksheets is you can just use paper and pencil and print it out. You'll have to figure out a way to get your paper image back into an electronic document form. So if you have a really good camera, you can just snap a picture. If you have a $25 camera, that's not going to work too well. There used to be a scanner in the Magic Lab. I don't know if it's still there. Scanners are the best way to convert paper to electronic. Just put it in a scanner. Magic Lab is free. You might have to pay for the paper. Don't know. Most years you don't, but some years you do. I don't know about the Magic Lab. I know about the library. Okay, you should actually do this exercise on a sheet of paper. Use this UML-like diagram to create two different dogs. Hit the pause button, get that done. I'm going to go to the answer now. This is what I did. I said, well, I'm going to use this UML-like diagram to make a dog object, and I'm going to set the name of my first dog to Barky, and the name of my second dog to Paws. And so I already now have two different dog objects because they have different names. But I can also change the age. I can set Barky to age 1. I can set a Paws to age 2. And I can also change the weight if I want to. Weight is 20. Weight is 10. This is a tiny dog. 10 pounds. Is that even a real dog? I guess it is. Maybe a small dog. So how do you get different dogs? Well, you change the value of the properties, right? Change the name or change the age or change the weight, change all three or change only two, whatever. But something has to change. At least one of these has to change if you want to have two different dog objects. Hopefully this is making sense. We're going to spend some time looking at this. This is much more realistic. The odds that you're going to be doing UML-like diagrams for a video game, probably not very high. The odds that you're going to use UML-like diagrams for abstract things that do math, very high if you're a software developer. So this is our introduction into that world. The name of this class is two numbers, and which means this thing can produce two numbers objects, okay? Has two properties, number 1 and number 2. This first method is to constructor. This is what we use to create a new two numbers object. We'll worry about that later. But here are all the things you can do to these numbers. You can add them, you can subtract them, you can divide them. Now, the next thing you can do is modulus. Now, if you don't know what modulus is, don't send me an email as saying, what is modulus? Because I'm going to send you an email right back that says, you can chat GPT that or Google it. Okay, you're in college now. You should be able to learn how to figure stuff out. You see words you don't know, look them up. All right. This isn't elementary school anymore where you can ask your teacher anything and everything. That doesn't work in college. If you don't know what some of these words are, look them up on ChatGPT or go to Google and find out what these things are. Hopefully we know add, multiply, divide, and subtract. They drilled that into us since elementary school. Okay. So what are we going to do with this class? Well, we're going to use this to do some math operations. So first thing I want to do is add 1 plus 2. And how do I do that? Well, I'm going to take the 1 and push the number 1 into the number 1 property. and I'm going to take the value 2 and push that into the number 2 property. So now I have number 1 set to the value 1. I have number 2 set to the value 2. Then if I want to add them, I just call the add method. And I would just write all this stuff out. Let's see, do I have an example of that? Maybe. Okay, why don't I just write an answer out then? I thought I had examples of it. I don't know. Notepad. We don't need that anymore. Okay, if I want to add 1 plus 2, I would insert 1. It's not typing. Why aren't you typing? Insert 1 into the number 1 property. Insert 2 into the number 2 property. Call the add method. That's it. That's all I want you to know right now. As we get further and further along, we'll figure out how to actually write computer code to do these 3 steps. But right now, I just need you to know what the steps are. Okay. So if I want to add 1 plus 2, first thing I got to do is take the 1 and put it inside the number 1 property. Take 2, put it inside the number 2 property. When I call add, it'll take whatever values in the number 1 property and add it to whatever values in the number 2 property and then return the result. So 1 plus 2 is 3. It's going to return 3. Hopefully this is making sense. Okay. All right, you do this on a sheet of paper. Multiply 2 and 12. Hit the pause button and write the answer down. I'm going to move on to the answer, but you can hit the pause button. Yeah, I do have an example right here. So I'm going to set the number 1 property to 2. It means I'm going to put 2 inside the number 1 property. I'm going to put 12 inside the number 2 property. Number 1 will now have the value 2. Number 2 will now have the value 12. I want to call the multiply method. Well, 2 times 12 is 24. So we're going to get 24. So where's the multiply? Right here. I would call the multiply method and I would get the value 24 out of it. Hopefully this is making sense. All right, so now we're at the dean's objectives. So I want to spend a little bit of time talking about this. Remember I said I'm going to talk a little bit about it for like 6 lectures. No, we talk about it almost every week. Yeah, well, forget about the 6 lectures. It's almost every week. This is so important. This is what the dean wants you to know. I said, yeah, if all your students know how to do all these things, then mission accomplished. We got it done. We did what we want. We educated them with what we wanted them to be educated about, and we have proof that they actually learned it. So the first step is develop solutions to programming problems. So in this step, I'm going to give you a very, 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 very paint on the wall, watching paint dry on the wall type of problem. Very, very simple. And you would write the code, Java code to make that happen. We don't know how to do that yet, but I guarantee you by the end of the semester, we will. Okay. So don't worry about that. It's going to happen. Just something to look forward to for now. With proper syntax. Well, what the heck is syntax? Grammar rules. All programming languages have grammar rules. The English language has a bunch of grammar rules. An example of a bad misuse of grammar would be coming up with a sentence like store milk, go buy I. All the words are there, but they're so jumbled up that the sentence doesn't make any sense. So Java does have a bunch of grammar rules that you have to follow. Like, so in in English, all sentences have to end in a period. Well, in Java, all statements have to end in a semicolon. That's one of the grammar rules. Semantics is it follows all the grammar rules, but when you run it, you get the wrong answer. So if you're trying to add 2 plus 3 and you run it and it says 2 plus 3 is minus 246, well, then you know something is wrong because that's not the right answer. You got a semantic issue. An example in English of a semantic issue is red ate a mountain. That is perfect grammar. There's nothing wrong with that grammar, but the sentence doesn't make any sense. Red is a color. How can a color possibly eat an entire mountain? You can't. See, the sentence just doesn't make any sense at all. But it follows all the grammar rules, but it just doesn't make any sense. Okay, the programming cycle. So if you actually Google or ChatGPT this, you're going to get a lot more steps. I threw away all the stuff that didn't involve a software developer because that's what most of us are going for, who are computer science majors. And of course, we want to be a software developer. Not everybody, of course, but most of us. And so what are the steps that a software engineer would have to do? Well, the first thing we got to do is go get the requirements. What is the code supposed to do? And this is easy if you're a freelancer. You're a freelancer, you find a customer and you ask the customer, what do you want this code to do? And the customer will say, I want to do this and I want to do that. And if that happens, make it do this, that. And if this happens, make it do this. And you write all this stuff down. And then after he's done talking, or she, the customer, you agree on a price. So it's a negotiation, right? Well, I can do it for this price, but you'll have to knock something off the list. There's no way I can do all of it at that price. And then it's a negotiation. And so once you have your list of all the things that you're going to write the software for, then you're gold. You've completed this step. Well, what if you work for a company? Well, you're going to be placed on a programming team. And it is the project lead's responsibility to make sure everybody has something to do. Now, what I do when I'm a project lead is I just take everything that we need to do and just toss it all out there. So we use user stories. What's a user story? It goes something like, if I was a user of this software, I would like to be able to do, and then fill in the blank. And we get a bunch of user stories. You got to convert those user stories into requirements. So I just toss them all out. Toss them all out there and let people pick. The people who are really smart, really good at coding, it'd be really boring to them to pick something really easy. They would be bored to death. So they usually pick the most challenging ones. And they know if they don't pick the most challenging ones, the project will never get finished because they're the only ones who could possibly take those on. And so they naturally just go for those. The interns, sometimes they don't even know which ones are the easiest ones. I try to help them with that. So you want this one. If they can't figure it out. And then the rest goes to everybody else on the team. Not every project lead does that. I've been on teams where the project lead, they'll have a meeting like every 3 weeks and say, these are the things we need to get done within the next 3 weeks. And they'll just start reading the list off. And then as they come to the end of one list of one user story, they say, who wants to do that? And you can say yes, or raise your hand, or whatever. And then you'll be assigned to that. The problem is that they keep going down the list and you haven't picked anything. And then finally, oh, that's the end of the list. And now you're in a bad place because now the only thing left are the user stories that nobody else picked, which means there's a reason why nobody else picked those. There's something wrong with them, or it doesn't look right, or there's something odd about them, or it's something that's way out of the zone of expertise or something. I mean, because you didn't pick anything, then tag, you're it. I like to be on teams if they're going to do that, where they publish the list before the meeting so you can kind of look it over and then figure out which ones you're going to go for when they bring them up. But not everybody does that. Some people, yep, here's what we got to do, and they just start reading them off. So it's interesting, that's for sure. I've been on other projects where the project lead assigns each individual team member user stories, one or more user stories. So it's the project lead that does all that picking. And that avoids a lot of problems, right? You're going to give the hardest ones to your top software developers. You're going to give the real easy ones to your interns, and everybody else, it's whatever's left over. And so it's up to the project lead. How are they going to do that? Once you have your requirements, what do you want this code to do? Now you have to come up with, well, how in the world am I going to write code to do all these things? You got to come up with a design. Now, if you're writing a video game, this is a piece of cake, right? You get large sheets of paper, you write scenes from the video game, you scribble the names of the people, like I said. Well, you draw a stick figure and say, that's Gus. Draw another stick figure and say, that's Mary. And then what are they doing? So you write a description of what they're doing in the scene, and then you tape it up to the wall and you do the next scene, and you just keep doing that until you're done with the video game. And then you're going to step back and look and going, this is the most boring video game I've ever seen. And so now you're going to start ripping some of those pieces of paper down. You're going to start moving some of the other ones around. You're going to cross off things that you wrote and write new things, and you're just going to change it. And you'll keep doing that until you look at it and going, okay, that's a video game I would like to play. Well, what if you're not making a video game? What if you're making software? For this class, All of our designs are going to be pseudocode. What the heck is pseudocode? It is code written in plain, ordinary English that describes what the code is doing. It is written in English. You don't have to know any coding to do this. Everything is written in English. Now, what if you have to write hundreds of pages of code? Well, the only real choice you have is to break up your requirements into objects. So you're going to write UML diagrams. A professional will write real UML diagrams, not UML-like diagrams. UML-like diagrams, simplified version of UML diagrams. It's something I made up to make life easier. This is the intro class. We don't want to make it too difficult on the first day. That they're going to write a whole bunch, they're going to divide it up into objects, and then for every object, they're going to draw a UML-like diagram or a UML diagram. And then top section will be name of the class, middle section will be all the properties or characteristics of that object, and the bottom section will be all the methods or actions that this object can do. Then they have to come up with a brand new set of drawings to describe the interactions between these different objects. And then after they finished all of that, then they'll have to grab some more paper and they'll have to figure out how are they going to interact with external events like keyboard presses and mouse clicks and things like that. And then they're done. They've got their design. They figured out how they're going to write their code. So once you've completed your design, you go into coding. So for this class, it's going to be Java code. We won't start Java. Well, you are going to have a first assignment in Java, but then we're not going to see it again until midterms. And then once we reach it, then we finish the class with Java. And so every lecture after that will be on Java. Look, we're going to learn something about Java. You're going, why Java? Why can't we just stick with Alice? Alice is fun. Well, because you can't get paid 6 figures at a tech company if the only thing you know how to do is to write Alice programs. You got to learn a real programming language that's used in the workplace. And that could be Java, it could be Python, it could be all kinds of things. I picked Java because I think it's the easiest language to learn. I know a lot of people disagree. They say, no, you're wrong. It's Python. Yeah, it is Python if all you want to do is write hello world. Once you go past writing hello world, Python gets complicated really fast, whereas Java doesn't. Its complexity always kind of stays the same. So I think Java is the way to go. Java is an object-oriented programming language. It forces you to use object-oriented programming. Python is also an object-oriented programming language, but you can go around all that object-oriented process because it's not required to be in your Python code. I'm telling you though, if your goal is to become a software developer and go work for a big company, then you have to learn how to do these UML-like diagrams, how to interpret them. You have to know what a property is. You have to know what a method is. You're going to have to know how to create objects, how to set values to properties, how to call methods. You have to do all these things. If you don't know how to do it, you're not even going to make it past the job interview. It's just a basic requirement, which is why we're starting out so early. It is the most basic requirement for getting a software development job. So that's why we're doing it. Also, you're going to write your Java code. Once you're done with your Java code, you're going to test. And this is where a lot of people lose points. They say, well, you're testing for bugs. No, you're not. You want to get paid. Remember that first agreement? You as a freelancer, you made an agreement with some customer saying, if I write code that does all these things, you're going to pay me this amount of money. That's your goal. You want to test to see if you met all the requirements, so you're going to get paid. Now, what if you work for a company? Same deal. You're going to have to work with the project lead to figure out how they want testing done. So some project leads, they're going to make you go through the whole thing like use freelance, that they're a freelance customer. You're going to have to show them, okay, here's a requirement that does this. Now run the code and show me it does that. Here's a requirement that does this other thing. Run the code and show me it does. And you're just going to go through the entire list and to prove that you have your program meets every single one of those requirements. Other project leads don't do that. What I do is I tend to just tell people, write unit test that covers every requirement. So a unit test is an automated test. They have to figure out how to write it, and they have to figure out how to make it test the user story, the requirement in the user story. But once they've got it done, then it's stored there forever. You can just run it anytime you want. Other projects, especially at larger companies, they have entire departments full of people, and all they do all day long is test other people's codes. So in that case, you would write a test plan. All the steps that a human would have to do to make sure that they're testing the software to see if it covers all of the requirements. So it's a lot of writing. A lot of times it's just a checklist. Do this. Do you see this? Do that. Do you see this other thing? But you have to cover every single requirement. Okay, so let's say we tested it, everything's good, and we sell it. Can we still make money after the sale? Well, you can't. We go into maintenance mode. So if you're the freelancer and you sold your software to the freelancer, that freelancer probably owns a company. What is the freelancer going to do? He's going to distribute the software to the employees that need it. Like HR software will go to HR, inventory will go to inventory people, things like that. Now, people hate change. They are going to complain. They're going to write up a lot of stuff that was silly nonsense, like, I don't like the color. I don't like the font choice. I don't like this. I don't like that. But some of the complaints are real. I can't do my job because this program won't let me do this, or there's something wrong. Whenever I try this, there's a bug and it's not going to work. And those are real complaints. So you're going to get a list of complaints from the employees, and you're going to go back to the person who you sold, who you paid money for to write this code, and saying, okay, we need some changes to make. You got to fix these bugs. We got to add this new feature in there that my people need. You got to do this. You got to do that. And then again, it's a negotiation. The two, you as the person who owns the company and the person who wrote the software, will come to an agreement on, for this amount of money, I can do this amount of stuff. Now, if you have software that sells millions of copies, like a video game, you can tell your customers, hey, for a monthly subscription, you get all the updates for free. And then what you're doing is constantly updating the software. So you might release like once every year a new release, and the ones who are paying the subscription fee, they get a free copy. The ones who don't, jack up the price really high to force them to sign up to pay, to join to pay the monthly maintenance fee. Or they'll just say, I don't want the monthly maintenance fee. I just want to do a one-time only deal. So whatever. Everybody's different. Everybody has different requirements. But maintenance is stuff that happens after the sale. How can you keep making money off of this sale? Pseudocode is code written in plain, ordinary English that describes what the code is doing. Now, I use it as my design. So what I like to do is take my pseudocode and paste it into my actual code, and then turn all of those things into comments. And then each comment, I would actually write the real code that would do that task. And so I'm accomplishing a whole bunch of stuff all at the same time. Not everybody does that. In fact, very few people do that, but that's what I do. It makes it real easier for me to figure out what code I'm writing. And then, 2 years later, when I have to go fix a bug, I can see my comments as, oh, I remember this, because I'm reading in English what the code is doing instead of reading code trying to figure out what it does. Not everybody does that. In fact, very few people do it. I wish more people would do it. It sure make coding a lot easier. So that's pseudocode. It is the design written in English. A comment is, it'll describe what the next line or a couple of lines or 3 or 4 lines, what the next few lines are doing in the code. And you just write a comment above the line or right next to the line or somewhere close to the line saying, this code is going to make my character walk, or whatever it is. And that's a comment. And with that, that is the end of lecture 1. I'll see you next time. Bye.